Well, so this chapter is all about you'd like to use a title of this lecture like mathematical expediency, just to make you aware of interesting and useful technique of mathematics without going to the detail of mathematical thinking, what is required for in-depth understanding. Rather you'd like become like a means qualified technician in electrical engineering who can who might be like who can means who is having more hands-on experience on fitting your electrical switches, electrical means doing circuits and wirings for your household appliances, but it's less skillful and may not be able to provide you all the things that he's doing there, but he is very confident of doing that because he is trained to do so. So here in this chapter also, or sorry, in this video also, my objective, because why I just would like to consume 1 or 2 minutes to explain my objective, because once you align yourself with the objective of this video, then only you can grasp it. Otherwise, it will what would happen that I will try to do something from my point of view, you will get something from your point of view, because now we are not physically present in person. So while the advantage of physical classroom is that I can read your facial expression and I can understand that what are the difficulties you are having. Obviously, it is very difficult for me to means read every 80 or 90 students who are present in the classroom, everyone's facial impression, especially those unwilling students who try to means use the comfort of backbench to enjoy some power nap after their lunch. So those things, but still, at least I can means read the facial impression of, or at least the pulse of the class. I can understand. Like if it is out of 80, if at least 50 people are listening to me, then it's somewhat meaningful. And if only 20 people are trying hard to get what I am trying to say, and rest of the 60s are busy in enjoying their power nap or doing chit chat or gossip in their phone, so then the lecture is absolutely meaningless, whatever be the content and what means how impactful means whatever it may be, means it actually makes no sense. Similarly, but unfortunately, like here, when I am trying to deliver something in online mode, I cannot read anything, neither I can sense your pulse. So it is first and foremost, before I start every lecture, I would try to explain the objective. So here the objective of delivering this lecture is to make you acquainted about certain tools that you will find handy, but you may not know that why the tools are crafted in such a way. Like a technician doesn't know why means, or may not be aware of that a hammer is a third kind of lever, or what kind of mechanical action takes place, how his motor neurons trigger it. All this he doesn't care. He is very good at means handling that hammer, and he can do the best use of it. So being at your stage, it is sufficient for you to be have that means just have means get acquainted with those mathematical tools instead of having an in-depth understanding of them. So first of all, I would like to start with norm of a signal or a vector. First of all, I would like to take an example of Euclidean norm, how we define Euclidean norm for an n-dimensional vector. If X is an n-dimensional vector, then we will like to define it like so. Basically, you are going to get something like right. This is the Euclidean norm, and sometimes what we do that like we can write some other formulas like this is also a straightforward means generalization of what is there. Actually, this idea of norm comes from the idea of metric. So, what is that? The idea of metric. The idea of metric is like it is something that is. Just let me write this line, otherwise I will not be able to means write it correctly. The idea of metric is like idea of means it is something that is useful in analysis where you are mainly interested in figuring out the like the distance between 2 points. So whether suppose you take a two-dimensional vector field and let me give you 2 points. Obviously, these 2 points on a two-dimensional vector field represent means two vectors. Let one be 0, 1, another one be let me draw it, then you will get it more clearly. Let one point be 0, 1, 0, another point be so what metric means? Metric means when you can have a particular unique measurement, the way you will define the measurement always return you a single value for all the points in that space. So when we are talking about metric between this, we can have metric like one metric maybe something like absolute value of, say this is our x1, this is x2. So these are the two vectors. Now we can have absolute value of x1 plus absolute value of the x2. So this will return us 2. Another thing what we can have here, like what you are doing here, basically you are measuring the length of the vector from origin and then you add them to get your distance. This is one kind of metric. This is known as taxi cab norm, or we often call it one norm. What is Euclidean norm? In Euclidean norm, what you do is that, say if you consider these axes are, so this is v axis, this is h axis, horizontal and vertical axis. So what you do, x1h minus x2h whole square plus your x1 v minus x2v whole square. You do it in this way and then you perform the square root. Actually, the common formula for pth norm of a vector is what we wrote here is that something like for an n-dimensional vector, oh, sorry, I just made a mistake here that I should write here. Yeah. So what is the formula for pth norm? In case of pth norm, you just take absolute value of p. Why absolute value is required? Because norm is always non-negative. You cannot have a distance between 2 points that are negative. If they are apart, you will always get means positive distance between them. Now, why this like absolute value is required? Suppose somebody is interested in calculating 3 norm. So what you will have? You will have that to the power 3. Now, if you do not put the absolute sign, what will I will have due to some particular typical vector with negative part, you may end up with a negative result that is not desirable. So always norm is always a non-negative measure, and it always reflects some kind of distance between 2 points. Well, now let us write a few. Mainly, we'll discuss Euclidean norm or 2 norm, and for Euclidean norm, let me write a few properties. As I have already mentioned, Euclidean norm is always non-negative, then it is 0, like norm of this is 0 if and only if your x is 0. That means for all I, like xi is equal to 0 for all I is equal to 1 to n, right? Then absolute value of alpha, where alpha is a scalar, can write it like alpha belongs to R. Now there a norm must like obey triangle inequality. And it must also obey something that is known as, I'm giving you a particular view of that this is a triangle inequality. Let me write Ti to make you understand. And this one is known as Cauchy-Schwarz inequality. So what is that Cauchy-Schwarz inequality? See, you will get an entire 1 hour lecture on Cauchy-Schwarz inequality, but don't ever think about learning of Cauchy-Schwarz inequality at this moment unless you are keenly interested in mathematics, because this will consume a hell lot of your time and without of any meaningful use. When you can't use that whatever you will spend by watching that video on Cauchy-Schwarz inequality, if you are not interested in mathematics, that is going to be complete waste, right? Now you let us, oh god, I have reached the end of this page, but one thing I would like to mention here, that whenever don't develop a notion that x needs to be real all the time. X can be complex, and in case you are having a complex x, for realizing Cauchy-Schwarz or whatever, you must replace x by xh, whether here or here. It is Hermitian of X, where you replace all the element vector by your conjugate transpose. If x is complex, like if your x is something like this, two j, then its h will be something like got it? Well, so that is what is. Now, as I said, that chapter is all about providing you some hands-on experience on mathematical understanding. Without wasting any time, let me jump to matrix. Now, when it is matrix, whatever you know about matrix, I am not going to discuss them. But obviously, a few things that you might have forgotten or may not be aware of, all those things that I would like to discuss. Like, we know that matrix addition is commutable, but multiplication of two conformable matrices are like not commutative in general. Like AB is not always BA, or it's not in general BA. Then if A is square, then for a non-negative number we can define a k, and with that, if k is equal to 0, we will get an identity matrix, and if for any value of positive k, we get ak is equal to a null matrix, then this A is called nilpotent. What is example means where we will need this nilpotent, we will discuss definitely, don't worry. Now if we have another useful property, I hope you still remember them, and if you have forgotten, please watch the videos of Professor Strang from MIT, so you will get it. Now, what is trace of a matrix? Trace of a matrix is something like well, and undoubtedly trace of AB is equal to trace of BA, although even if AB is not equal to BA. Now, what we can write the next, the important formula, that is that just a minute. Yeah. Okay, so while we are discussing about trace, now let us discuss something, that is how to find out the norm of a matrix. Let us consider a matrix A is something like this. Or in some cases it can be n cross m. That is, I think you have that maturity to understand this, that exchanging m and n, how it impacts on that matrix, and we'll carry out. So this is the one norm. Like one norm of a vector we have discussed. The one norm of a matrix is like something. Well, then you have two norm is given as this one denotes the largest eigenvalue of the matrix A transpose A. Right? Maximum lambda of this means it indicates largest eigenvalue of this matrix. And obviously last one is that as I have made it very clear that I am not going to discuss something that is your like why we define this and what are the means in-depth understanding behind this definition. I am not going to discuss them because that would take a hell lot of time of no good use. So that is why I just keep it simple. It is for your information. So whether in some later stage if I mention some points, you can figure it out, right? So this is all about our matrix. Now we'll go to something that is known as quadratic form. So what is quadratic form? Like for a specified matrix n cross n matrix Q, belongs to your R n cross n, and if you have a vector x to R cross 1, just a minute. So x is actually not Rn cross 1, rather better to write Rn. There is a difference between Rn and Rn cross 1 anyway. So if that is the case, then what we can do, we can express it without loss of generality. We can consider that xtqx is a symmetric matrix. Like what quadratic means, what we mean that like we can represent it. If it is symmetric, then what about Q? And the quadratic form represent now obviously the matrix which are not like not symmetric, they can be represented by a part of like means just so once you represent this in quadratic form, obvious condition is that it will result you in a scalar quantity, and if you find that the outcome is greater than is equal to 0, sorry, greater than 0, then we call this is positive definite. If it is means negative of this is greater than 0, then we call it negative definite. If it is equal to, then it is positive semi-definite, and if it is negative is greater than 0, then it is negative semi-definite. Do remember this definiteness is not mandatory. Like even if you represent it in quadratic form, still you can have sign indefinite things present in your system. So that is not so easy to comment about. If you ask me about sign indefinite things, let me show you something. Uh, like what is an example of positive definite function like x1 square plus x2 square. So you will see that in a two-dimensional plane, for all combination of x1, x2 other than is equal to 0, you will have x1 square plus x2 square greater than 0. And this can be represented in quadratic form like x1, x2 Well, what I was about to talk about means I was about to mention, but then I forgot. That is what was like your if a matrix is not symmetric, then obviously the sign definiteness or this cannot be taken in consideration. For consideration of getting sign definiteness, your matrix has to be symmetric. So this one has this condition has to be satisfied for matrix means representation in any sign definite form. But for like non-symmetric means asymmetric matrix like you can have this kind of like so what it will give you, it will also give you something like so this is a matrix that is not symmetric, right? So this form you cannot say it's a like a sign in a sign definite form, because although this one eventually if you try to figure out, it will satisfy the criteria of showing you sign definiteness. But now I am going to discuss something that is very important and known as Rayleigh inequality. What is that Rayleigh inequality? Oh God. In Rayleigh inequality, we can write it like so. This lambda mean and lambda max, they denote the smallest and the largest eigenvalue of your matrix. Right. Now, what you will have is that what more we can write, like if you we often say that for positive definite Okay, one more thing I would like to share here, that how you can test a matrix is positive definite. So for a symmetric, let me write, otherwise you might have missed things. What do you need to check? Suppose a matrix is given, or consider a polynomial is given, say x1 square plus 4x2 square plus 9x3 square minus 1.25 x1 x2 minus 20 x3 x1. This polynomial is given. Now we have to check that whether we can represent it in a quadratic form or not. For quadratic form representation, it is mandatory that you must have all this square or this kind of means if your expression contains something like this, then you cannot express it in quadratic form. Now if you are interested in representing it in quadratic form, this function, then how you can write it? Like here you consider one vector x transpose, here one vector x. Now you keep on writing here 1, that is x1 square coefficient, here 4, that is x2 square coefficient, here 9, here x0 square coefficient. Then you symmetrically divide these off diagonal elements like 0.625 here, 0.625 here, then you have minus 20. Similarly divide it in two places. This is 1 3 position, this is 3 1 position, and as x2 x3's coefficient is 0, you place 0 0 here. So that is the quadratic representation. Now you have to check that whether this function is sign definite or not. So how can you check it? You have to check the sign of the successive leading minors. Like here, first you need to check this sign. Well, this one is positive. Then you increase the size of your minor. You are moving in this direction. You have to check this one. Clearly this is going to be a positive number. Then you have to check this whole thing. So if this whole thing results you something that is positive, then it's well and good. Otherwise your matrix is not positive definite, or it's sign indefinite. If it comes out one more interesting thing I would like to mention for a case of negative definite. So let us take an example of negative definite function like minus x1 square plus minus x2 square minus x3 square. So clearly this is a negative definite function, all the time negative rather than origin. You are having what? Basically you are having one negative identity matrix here. Negative identity matrix here. Now see the beauty when you form this kind of matrix representation, and when you try to check, you have to check first leading minor for negative definite. It is what? It is a negative number. Then you check that now what is the order of this minor? Order of this minor is 2, an even number, and see what you are getting. It is 2. Again when you will consider this, you will get minus 1. So what we write for negative definite matrix, you should get minus for all odd order minors plus for all even order minors. And obviously positive definite and negative definite will be the case where one of your minor will give you 0. That is the case when it is be positive and negative definite, semi-definite. And if everything is like hodgepodge condition, like it toggles the sign or means it violates this kind of particular sign requirement, then it is sign indefinite. Now, there are a few important theorems that I would like to discuss here. Without, if we have a matrix A with some entries like how to perform entries like integrate a matrix and differentiate a matrix. Perhaps the differentiation is easy, like point-wise differentiation, but about integration, you can also think about that integrations like it will be also easy if you consider it like this be A and like entry wise it is easy to understand, but what about the total representation? So by the total representation, what I am trying to say, like if we consider the fundamental theorem of calculus in case of matrix, what we can write is that or you can say a tau d tau, and if we apply the Leibniz rule, then what we will get, that is so. This is one Leibniz application of Leibniz rule in this matrix calculus, and like, but one thing we must be very careful that if you take what makes it different, like if you take something, what you get is that, but if you take a matrix here, then you should get or this kind of things. So that is quite different than that of writing 280 a dot t, right? And also we now go to the case of understanding convergence. That is the last topic in our mathematical discussion. Why convergence is necessary. So why convergence is of a sequence? Convergence of a sequence is very important for us. Like, although the objective of this chapter is as I have said, it is a mathematical expediency, development of your mathematical expediency, but it is something that until unless you understand sequence and convergence, you will not be able to do anything in your real life, because in real life things are not so good looking, they are not so gentle as they appear in your theoretical study. Rather, they are very rash, and they are like they are like just like an unruly crowd. So if you want to handle them, what is the way is that most of the times, instead of finding out the solution of the system, what we do is that we try to figure out bound of that same thing. For an example, I can give you one example. Suppose if you have a time varying system, intuitively we can define two extreme system. Those are time invariant in nature, but these two systems being invariant, one is representing the lowest value of variation, and the other one is representing the highest value of variation, and for these two we are trying to figure out the solution, and in between whatever variation will take place in our system, we will conclude that our system solution will always lie in between the two extreme solutions. So therefore, and also sometimes what happens that instead of getting an exact solution, you will have different solutions. So those solutions itself may form a sequence. So at that sequence, the entries of that sequence are not scalar, but they are the vectors. Like all the entries in a sequence, they are say n cross 1 means n dimensional vector. So an infinite sequence, let me now write that an infinite sequence for sake of simplicity I am writing Rn, but it can be Cn also. Cn means vector with complex entries. Like we can have this belongs to C3, right? So is written as like some people like to start from k is equal to 0 to infinity, or other who is trying to maintain a more physical sense here, because a physical object cannot be placed or cannot be considered that having an index 0. So they started from k is equal to 1. So it is your choice. Whether you consider it k, m, whatever, it is your choice. Now, a vector. So basically, what is your solution? After you wait for certain time, I'm also means in my future means upcoming lectures I will discuss more about solution. But whatever we have discussed as of now, you can figure out the solutions are like they are also n-dimensional vectors. Like solution of a single differential equation, like a first order differential equation, is what? A single scalar. Now in your state variables, how many number of such means single scalar variables are there? N number of scalar variables. For them you will have n number of solutions together vertically concatenate with each other. So they will form, in a nutshell, they will form an n-dimensional vector. Even the solution is an n-dimensional vector. Now when you consider that n-dimensional solution vector, our interest is that what I was trying to say, that what they do they converge, right? So what we can do is that it is we can write that a vector x cap is called the limit of sequence if for any given n greater than 0 there exist, sometimes I may use this symbol to indicate there exist positive integer capital K E epsilon. So epsilon greater than 0, this K depends on epsilon. It is like a function understanding, such that what we can have is like the two norm oh god So what it says, a vector x cap is called the limit of the sequence if for any given epsilon greater than 0 there exists a positive integer capital K which is also a function of epsilon, such that the limit, the difference between the limit and this one is less than this epsilon when K greater than K epsilon. So if you want such a means like obviously in a nutshell, if you means if you ask me for certain example, let me give you one thing that is for scalar I can give you something like just a minute. Yeah, so it is 1.4, then the next one is 1.41, then the next one is 1.414, then the next one is 1.414 to 1.41421. So first of all, try to understand that this sequence is finally going to convert to root 2. Why I have taken example of that sequence, that is also very interesting, because if you consider like if you are committed to pick up elements of this sequence that belongs to this Q is not a matrix, this is the set of rational number rational number means you can express them in P by Q form. So if these elements they are like xk, all the elements you pick from set Q, you will see the beauty of this sequence is that finally they are going to converge to some point that doesn't belongs to Q, but they are going to converge it. And here another thing that is very important, I was discussing or hinting towards that completion of sequence, but for the time being let us drop all those complicated concepts. Let us see that what is K. Here K is equal to 1, K is equal to 2, K is equal to 3, K is equal to 4, K is equal to 5, K is equal to 6, so on. Now what is capital K? Suppose you bring that epsilon is equal to say 0.005. So if you take this 0.005, what you are looking for? You are looking for such a value of K. I do not know which value will correspond, so that you get something like your limit vector, or in this case limiting value is √2, right? This root x is √2, so you are having here √2 minus that 1 like we can take absolute value, √2 minus that sequence. What is the value? You can take any value, say such that. So one thing is clear, that if you go on increasing appending elements in this sequence, the rule we have implemented to construct this sequence is that, so the consecutive members that we are going to pick up from set of all rational numbers should become more close to √2, and we are going to means increase our decimals places. So let us take 1.4142, that is at K is equal to 5. So what is the distance? So what I could calculate, that even at K is equal to 4, if we cross K is equal to means 4, for that only we can get this condition satisfied. So for K is equal to 4, it is becoming, so our K epsilon, we can write this K epsilon, depending on this we can select this K epsilon is how much? This is 3, right? So we are getting all the values of this greater than means whenever the index value is greater than 3, then it is getting less than is equal to 0.005, right? Now this is all about your sequence. Now we'll have to consider the series of vector function. Like, I hope you must understand the difference between series and sequence. So series of vector function is like an infinite series of vector function. Well, yeah, where your xjt, if it is now we can say that convergence is defined in terms of the sequence of partial sums. What is that sequence of partial sums? It is SKT is equal to right. And what is series convergence to a particular function? Series convergence to a particular function is something like, if this is the point where the function does converge, that series, we can write it like limit for all things, all this means math, whatever I am doing here, I cannot provide you examples here in this video, because this video will then consume some more time, and I am means there is a strict restriction imposed on me that I cannot exceed 40 hours. So it is requested, means like it is a request to you, that you people are requested here that you please interact with me and try to, like, first of all try to figure out the examples by your end and try to interact with me to clarify your doubts and whatever questions that comes in your mind. Otherwise this subject will remain an kind of untouchable things for you that you will never be able to handle. So even if you do not understand this series sequence properly, soon I am going to discuss a few examples while solving the solution of a linear system. But it is your duty, whenever I discuss some mathematics, try to validate or counter it with some examples. Until unless you are ready to pick up examples by yourself and try to draw a picture of that mathematical representation in your mind, you will not be able to grasp it, or not be able to gain the full confidence on this topic. We are engineer, we are not abstract, going to deal with abstract mathematical thinking. So for each and every mathematical representation, you should have a pictorial view in your mind. So try to do that. In our next lecture, we will discuss solution of linear system.